NPTEL Ethical Hacking Course Assignment number 1 Answers 2022. Question number 1. Which of the following statements are true with respect to penetration testing of the network? Penetration testing methodology, we have 4 different type of testing: tiger box, white box, black box and grey box. 4 different types of penetration testing we have. Let's see the option. Here they have given white box, black box, grey box and red box. Red box is not available in the standard methodology, so we can eliminate the option D. Next, let's see about white box, black box and grey box. Black box, the tester will not given details about the network. White box, the tester is told everything about the network topology and the technology. The grey box model, hybrid model, it is the combination of the both white box and black box. Here the company gives to the tester partial information. Let's see the option A, the white box model, the tester has complete information about the network. Option A is correct. Next, in black box model, the tester has complete information about the network. It is wrong. No information given to the tester. Next, option C. In grey box model, the tester has given partial information about the network. It is also correct. Answer A and C. Let's move on to the question number 2. Which of the following statements are true for the packet switched network? Option A, a point-to-point communication link may be shared by more than one end-to-end connection. Option A is correct. Option B, a point-to-point communication link is dedicated to the connection and cannot be shared with other connection. Option B is wrong. Option C, the packet transfer delay between the pair of nodes is more or less constant during the entire period of the connection. Correct. Option D, the packet transfer delay between a pair of nodes may depend on the prevailing network traffic. This is also correct. So the option A, C and D is the correct answer. Let's move on to the third question. A packet of size 5000 bytes is sent over the 100 kilobits per second kbps point-to-point link whose propagation delay is 5 millisecond. The packet will reach the destination after dash millisecond. We know 1k is equal to 1000. So 1 byte is equal to 8 bits. Now the size of the packet is 5000 bytes. We have to convert it into bits. So 5000 into 8, we got a 40,000 bits. We know 1000 is which is equivalent to k. So here we converted the 40,000 bit into 40 kilobits. Already they have given the problem itself. What will be the speed? The speed is 100 kilobits per second. So we have taken the same. Then we have to calculate the time. So to calculate the time, we have to write the formula, that is size of the packet divided by the speed in seconds. So the seconds, 1 second is equal to 1000 milliseconds. Now we just keep 40 by 100 as it is. We convert the second into millisecond. So we substitute the 1000 here. So after doing the computation, we obtained 40 into 10 milliseconds, that is 400 milliseconds. So the packet will reach the destination after 400 plus 5, which is equal to 405 milliseconds. Question number 4. Which of the following OSI is responsible for node-to-node routing packets? So we know the OSI layer model. We have 7 different layers are there. So here physical layer, no way related to routing. because it's just sending the information as zeros and ones. Transport layer end to end delivery, that is the source to destination, exactly the information has to be sent. This is the responsibility of transport layer. Network layer, it decides the route. Data link layer is the responsible for one node to another node information delivery. So the correct answer is a node to node routing packets, data link layer. Okay, next let's move on to fifth question. What is the purpose of port number in TCP/IP networks? So the purpose of the port number, let's we see the option A. It is uniquely identifies the network interface of the computer system. It is uniquely identifies the host in the network. It indicates how many hardware ports are there in the computer system. None of this. Here everything given the information, nothing will suits for here. Let's we see what is the purpose of port number. Port number, here the good example explanation here. Port can be treated as the gateway to internet to facilitate different applications to make the connection at the same time. Each device connecting to the web user ports in different manner. All operations are carried out using different ports when we simultaneously use the web, download some files, use printer, etc. For example, HTTP transfers uses the port number 80, whereas a telnet uses 23. Like that, each protocol you have a separate port number. Let's we know what is a network port. Network port facilitates in identifying application or service running in the browser or computer in the same fashion as IP address does. Looking into the analogical situation, for example, supposedly you own a building. The street address corresponds to IP address. The way there is the port number, each building also has its own building number. That is equivalent to port number. Now let's we see what is port number. Port number also of different types and have unique numbers. The ports coexist within the IP address because each and every services has its own unique port. Top firms like Google or MSN use well-known ports. The number 0 to 10,231 for their services. Certain specific functions are assigned registered ports 1024 to 49,151 when requested. There are also private or dynamic ports of 49,152 to 65,536, which can be used by anyone who wishes for private servers and temporary purpose. So note these points, it may be useful for in future. Client port numbers are dynamically assigned and can be reused once the session is closed. Which of the following statement is true for TCP protocol? It provides a connection-oriented, reliable packet transfer service. It provides a connectionless datagram service. All packets from source to destination follows the same path. It routes the packets from one node to the next. The correct answer is A and D, because TCP/IP itself we have two different type of protocol. One is TCP, another one is UDP. TCP is the connection oriented, reliable and doing the transfer service. The UDP is the connectionless service, that is datagram service. It is also doing the transfer service, right? All packets from the source to destination, it is not at all possible. The route it will be desired, it may differ from router to router. So here the correct option is A and D, because TCP is the TCP protocol is the connection oriented, reliable. UDP is not reliable. The both we cannot give the assurance, even TCP and UDP. Each packet from source to destination follows the same path. It is not at all possible. So B and C won't come. The answer D, it routes the packets from one node to the next. So answer A and D is correct. Next, question number 7. Question number 7. Which of the following are valid port numbers in TCP/IP? Already I told you, when we read which of the following port numbers are valid. So the port numbers range we have seen here. Once again I recall, the port number range is 0 to 65535. Actually the maximum value is 65,536. It starts with 0, so that it ends with 6,335. So see here, 10,000 comes under less than 65,000, so it is the valid port number. 50,000 it is less than 65,000, so this is the valid port number. 1 lakh it is greater than the 65,000, so it is not a valid port number. So all the C and D, E greater than 65,000, so it is not a valid port number. So the valid port number must be between the 0 to 65,536. So easily, if we know this concept, we can answer both the questions. Let's see the next question, 8th question. If the IP header is 256 bit long, what will be the value of H length field? Here the answer is none of this, no value will come. See here how it is. Let's see the formula. H length. H length formula is IP header by 4. Okay, let's read the problem. The IP header is 256 bits long. Let's see IP header 256 bits. Let's convert it into byte. So when we divide 256 divided by 8, we will obtain 32 byte. Now this is the 32 byte is the IP header value. Already the formula itself, H length, we have to calculate IP header divided by 4. So 32 by 4, the right answer is 8 byte. Let's see one more example for this problem. The IP header is 192 bytes long. There we have seen bits. Here you can see 192 bytes long. Here we should not perform any byte conversion. The question itself they have given bytes. There they have given the question itself bits. So I have done the conversion. Okay. See here this problem, they have given the information 256 bits, but here they have given 192 bytes. So what will be the value of HLN field? So we have to apply the formula. HLN is equal to IP header by 4. So 192 by 4, 48 bytes. Answer for this question. Ninth question, the maximum size of the data that can be accommodated in the IP datagram is dash bytes. Maximum size 65,535 it can accommodate. Let's move to last question. Let's remove the last question. Which of the following statement is true? For small number of packets, datagram is faster than the virtual circuit. Okay. Next, second option, for the large number of packets, datagram is faster than the virtual circuit. It is not correct. Next, in the datagram, a dedicated communication path, where the dedicated communication path will comes when the connection oriented only, we can say the dedicated communication. It is the datagram connectionless. So it is also not correct. Last option D, in the datagram, it is not required to establish a connection between two end system. So this is correct. So answer A and D correct. Thank you.